Okay. So today we are looking at quadratic functions and sort of putting a few things that we've done together. And we have two forms that we use most often. You know standard form. We use standard form most often when we want to find the x-intercepts, or also known as the zeros. When it's in this ABC form, you have a special formula, the quadratic formula, that you can use to help you find those x-intercepts. What is the quadratic formula? X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2. Alright, so when you're in standard form, then you can use the quadratic formula pretty easily to find those x-intercepts. Now, so both of these are x-squared functions, and so they both have the same parabolic shape, and which means they're going to cross the axis somewhere. And so we can find these x-intercepts maybe this way if you're in standard form using the quadratic formula. And we can also find what's known as the vertex. And the vertex is the lowest or highest point of your parabola. So in this case, this is the vertex. In this case, it's a minimum because it's the lowest point on the parabola. And you can actually find that vertex in standard form pretty easily. And that vertex is an ordered pair. And you can find it, actually, it comes from the quadratic formula. The x-coordinate of the vertex is opposite of b over 2a. So that's easy to find. And once you find the x-coordinate, what do you do to figure out the y-coordinate? Plug it back in, sure. And so we denote that as f of negative b over 2a. And so that says, go to your function and then replace the x with the negative b over 2a, whatever that result is. And if you have these 3 points on a parabola, then those are great 3 points to have. Those are the 3 most important points on a parabola: the vertex and the 2 x-intercepts. Sometimes. Are there always 2 x-intercepts? Not necessarily. Why, sir?
The vertex could be above the x-axis.
Yeah, so we could be touching. Yeah. So what if that parabola was just touching that x-axis? Then that x-intercept also happens to be the vertex. Okay, so it's a 3 for 1. All right. Now, so standard form, we kind of have a lot of information about, so we've got good stuff going on there. For vertex form, your book is old school, so it's, I don't know. I will lovingly call this HK form because it has H's in case. Okay. I'll call this ABC form a lot. Okay. Every book has its own little name. I don't know why they don't call it by what they all have in common, which is A, B, and C, or H and K. But whatever. So this is called vertex form because the form gives you the vertex. The vertex, when you're in vertex form, is H and K. Now I would like you to pay attention to the sign here. In the formula, it's x minus h. But for our vertex, it's just h. Okay? So be careful. The K stays whatever it is, but the H is different. And the A has a special thing. We're going to learn more about this tomorrow, but this A is a vertical stretch or shrink, S-T-R-E-T-C-H, stretch or shrink. S-H-R. I can't write and spell today, evidently. And what that does is it takes our parabola and it either stretches it taller or compresses it shorter, okay? And it can also reflect the function. So it can be a vertical reflection. So if it's negative, then our parabola is arms down parabola, okay? This form, I think, is the most useful form. We can graph really easily in this form. We can find the zeros or the x-intercepts really easily just by setting f of x equal to 0. Just by setting it equal to 0, and then you can move the k, divide by the a, and take a square root. So you can actually use the square root method to solve, and it turns out to be pretty easy. I'm not sure if you have to do that today or not, because I don't remember. But we're going to be doing a little bit of graphing today in this form. And so we're going to be graphing in this form. We're going to learn more about this form tomorrow. It's my favorite form for graphing.
What do you mean why? I mean why?
What? Why?
What question is that?
The h and k, turns out that they're going to be taking a parent function. And so the standard y equals x squared graph starts at the origin. And that would be the graph y equals x squared. And then the h and k are transformations. Just like from geometry, when you would take figures and slide them left and right. So if I do, with the x, if I do x minus 2, then that's going to slide that parabola in the x direction 2 units. It's going to take the x and it's actually going to slide it to the right 2 units. And then if you add a number on the outside, the k value then translates vertically up and down. So that's why I like h's and k's. The h shifts us horizontally, left and right, and the k shifts us vertically up and down. Okay? And we'll talk more about that tomorrow. It's kind of an interesting thing. But today we're going to go straight with the vertex and maybe finding another point if we need to. So example 1, graph the quadratic function, label 3 points. Graph the quadratic function, label 3 points. All of these are in vertex form, but stuff may be missing or invisible. So I'm going to write down vertex form, x minus h quantity squared plus k. It's a good form to know and memorize. You'll notice I put y instead of f of x. That's just habit. They mean the same thing. They do. Like potato. All right. So, looking at this, what's the a value? 1. Yes, it's 1. Okay, that's good. And so we want to find the vertex. What is the vertex here? Positive 3, negative 2. All right. Remember, the vertex is HK. The negative is part of the formula. Okay. So we are subtracting the 3. So our vertex is at positive 3, negative 2. So I'm going to label that point. And then I maybe want to find 2 more points. The nice thing is this is the vertex. Every parabola has what's known as an axis of symmetry. And so it's the same on the left side of the parabola as the right. And so the nice thing is, if I can find one point maybe to the left, then I just get to reflect it across that axis of symmetry, so I don't have to do too much more work, okay? So what I'm going to do is I'm just going to pick a point either to the left or the right. So what's to the left of 3? 2. So I'm going to take 2 and just plug in 2 and see what we get here. 2 minus 3 quantity squared minus 2. 2 minus 3 is -1. Squared is minus 2 is -1. So I have the ordered pair 2, -1. I'm going to label that 2, -1. And by nature of knowing about symmetry, what must another point be? 4, -1. Yes. 4, -1 just gets reflected right across that axis of symmetry. It's the same on the left as it is on the right. And there's 3 great points for labeling and drawing my parabola. Okay, so super easy to find some points. The easiest thing to do is to find that point that's just 1 away from your vertex. Usually that's the best point. Okay, questions on that one? Letter B. Does it look like standard form? Doesn't quite look like standard form. Can we fill in the missing parts maybe? So -2, what's missing? There's an H. Yeah, there's an H. We have the thing being squared, but I'm missing. What's the H, do you suppose? 0. Yeah. All right. So you'll notice, would it be the same here if I wrote x minus 0 and then squared it? The 0 doesn't change anything, does it? Okay. So we would never write this in normal human. I don't want to write the -0. So you know that these mean the same thing, okay? And so what is our vertex? 0, 5. 0, 5. And what does that negative do? It's a downward facing parabola, so it's good sort of anticipation here. I am going to find one more point, so give me a value to the left or to the right of my vertex point. 1, yeah, so let's do f of 1. So -2 times 1 squared plus 5 equals 3. Very good. So we have the ordered pair input, output. So 1, 3. By nature of reflection, what's the other point? -1, 3. Yep. All right, and then we can connect to get 3 lovely points on our graph. Okay. And that axis of symmetry always, always, always passes through the vertex, which is why that's a great point to get first. Okay. No.
Does it matter what number you choose?
No. Yeah, it doesn't matter. So if I had plugged in -1 squared is still a +1. Times -2 would give me -2 plus 5 would give me +3 still. Yeah. So it really doesn't matter. And in fact, being 1 away isn't necessary. We could have tried 2 or 3 or 4, really any number. Just maybe you might need a bigger graph. I always just say plot and label, ladies and gentlemen. That's the most important part. Was that funny? All right, example 2. Find the x-intercepts and the vertex of the parabola. Bathroom, please. Awful. Okay. So 2 different cases here. What else do I have? I have Oh, I have all kinds of examples here. Okay, cool. So doing things the fast way is what you want to get good at. What makes the most sense? Is this standard form or vertex form? Or both? Both, actually. Yeah, so just like before, we could write it for quantity x minus 0 squared minus 11. So it is vertex form. And if it's vertex form, I can solve using the square root method. So I'm going to do that in just a second. But first, we're going to find the x-intercepts. It's in standard form. Ax squared. What's the b? 0x minus 11. So we have vertex form or standard form, and be wary of both. Since I have standard form here, I'm gonna go ahead to find the x-intercepts first. Right. X-intercepts, also known as zeros. How do you find x-intercepts? Yeah, set f of x equal to 0 or set the y equal to 0 and solve for x. Well, the easiest way to do that here is actually just the square root method. So we're going to do that. So I'm going to set it equal to 0, 4x squared minus 11. And I want to isolate x. What should we do? Add 11. And then divide by 4. So we get 11 over 4. And then what? Square root, both sides. Don't forget. Plus or minus, always, always. So we get x equals plus or minus radical 11 over 2. The square root of 4 is 2, so we can clean that up a little bit. So here are our x-intercepts. And if I want to find the vertex, then I'm going to use standard form. I'm thinking in standard form here. My vertex is negative b over 2a, and then plug that value back in to get the y coordinate. So I'm going to do that. X equals the opposite of b over 2a. What is the opposite of b? 0 over 2 times 4. It gets 0, right? And if I plug that in, 4 times 0 squared minus 11 gives me negative 11. So my vertex is 0, negative 11. So x equals negative b over 2a, really useful to remember to find the vertex. Plug it back in to get the corresponding output value. And that's what we need to find. All right, letter B. Not quite as easy. Is this vertex form or standard form or both? Just standard form. What's the difference between the two of them?
That one's missing C, while the first one was missing B.
Yeah, so this one only has the x being squared term because this has an x. It can't be this vertex form. Yeah. So this is just standard form. And I'm going to start by finding the x-intercepts. And so that's setting my equation equal to 0. How do you want to solve this equation for x? Double bubble, always a really good option. Double bubble, what else? What does this one have? Take out an x. We could do the quadratic formula, but this one we can factor. There is a greatest common factor of x. I'm actually going to take out negative x. Can I do that?
Absolutely.
Absolutely. So negative x comes out. What's left behind?
2x minus
2x minus 3. So I can factor sometimes, and that's going to be the easiest route to take. And then I'm going to set each thing equal to 0. Well, that means x equals 0. And here x equals what? 3/2. Yeah. So there's our x-intercepts. And if I want to find the vertex, how do I find the x-coordinate of the vertex? 2 times -2. Good. -3 over 2 times -2, which is going to give me 3/4 for my x coordinate of the vertex. And how do I find the y coordinate? Plug it in. F of 3/4. Let me know if I make a mistake. So -2, plugging in 3/4, squaring it, plus 3 times 3/4. And, you know, because I'm tired and I just don't want to do that, I'm going to use my calculator. -2 3/4 squared. That's a question mark? I didn't know my calculator did that. That's supposed to be negative. Oh, look at that. There is a question mark there. That's so funny. I don't know how to use that. Dang, I don't know something about my calculator. Okay. So I've basically just plugged it into my calculator, and I'm going to let my calculator do the hard work for me. And then, of course, my favorite function, mathfrak. Turns out it's 9/8. Mathfrak, ladies and gentlemen.
Okay, we don't have to solve that kind of thing on the paper, right? We can just use your calculator.
Oh, absolutely. You can just use your calculator. That's what they're for. All right. Questions so far? The mathfrak button under the math menu on the left. Left. There. Math and frac. Mathfrak. Very, very useful button. All right. Last one here, ladies and gentlemen. Is this vertex form or standard form? Standard form. So we have x squared plus 6x plus 10. I'm going to start by finding the zeros or the x-intercepts. Does it factor? No. So that means quadratic formula, yes. So quadratic formula. So again, factor first, ladies and gentlemen. If you can factor, that's what we want to do. It's easiest. So x equals the opposite of b plus or minus the square root of, b squared.
Minus 4ac all
Oh, I appreciate you guys. So great. All right. I usually put this whole thing in my calculator, but I can do this one in my head. 36 minus 40 is -4. All divided by 2 times 1, which is 2. And then I have -6 plus or minus. How does radical -4 simplify? 2i. Very good. Remember, negative under the radical, imaginary. Square root of 4 is 2. And then I'm going to divide each term by 2, which is going to give me -3 plus or minus I. Very good. So there's my 2 x-intercepts. And then to find my vertex, x equals the opposite of b, all divided by 2a, which is just -3. And then f of -3, -3 squared plus 6 times -3 plus 10. So plugging it back in, 9 minus 18 is -9 plus 10 is 1. So my vertex is at 3, 1. -3, 1, sorry. So -3, 1 is above the axis right here, which is why there's imaginary solutions. This is an upward facing parabola.
Do we have to put imaginary?
I do think it wants all real and imaginary solutions, yeah. Whatever it happens to be. So yes, it's an interesting point that because it's an imaginary solution, it doesn't actually intersect the x-axis. All right. So, and again, that's something you could graph and see on your calculator too. Double check, was I supposed to get imaginary solutions? Yeah. Do you have any questions for me? How's life? Don't grow up, man. Don't grow up. Being a grown up really blows. All right. Folks, have fun. There you go.